Hello everyone. Since I'm not only a woodworker but that I actually renovate my own house, I figured I would post the heat system that I designed myself, or actually put together myself. This is it basically. I have floor heating in the house now, water-based floor heating. So this is the pipes that goes out to the floor. So there's two for the living room. I think these are for the living room, office, kitchen, bathroom, and hallway. And I can adjust these depending on how much water I want to flow to each one. This is the circulation pump for the water. Have some temperature meters, so I can monitor the temperature going out to the floor. This is the return, so this is the outlet return from the floor. This is the heating unit, and it's basically like an electrical heater in a casement with water flowing through it. So water is coming in here from the return, it's going through the return in here. It's getting warm from the heater and coming back out through the adjustment valve out to the floor. So this is supposed to be connected to a thermostat in the house, so it feels what temperature the room is, and then it adjusts with the motor the mix between the heated water and the return water. So if it's already the temperature you want in the house, then it just takes 100% return water. Let's see if I can adjust this by hand. So now it's like on 100% return water, so now it's just circulating the same water around, not adding any heat. And there it's on 100% heating water, so then it's adding all the heat. And that's supposed to be adjusted with the motor, but I haven't connected it now because I'm not living in the house or anything. I have just set the thermostat for the electrical heater to 23, 24 degrees or something. So it will just pump out constantly a consistent temperature to the floor, and not like raising it or lowering it depending on the need. But now it's summer outside, so I don't really need to have I don't really need the heating system that much. I just want to I just wanted to heat up the floor from the winter because it's been standing cold. So that's basically how that works. So this I actually found on a scrap heap. It's on right now, so it's quite warm. I found it on a scrap heap, just the casement, and then I managed to find in my parents' basement there was an old oil burner with like a support electrical heater in it. So I took the electrical heater with the thermostat, and then I found on a scrap heap as well a relay switch, which I can take off the casement. Let's see, we'll pause. Okay. There we go. That's the relay switch. Focus. So yes, I found that one as well. So it's the heater is 6 kilowatts, so 6,000 watts, and it's running on a 3-phase. So these are the 3 phases, and the thermostat is basically two wires going in. So one feeding wire, and when the thermostat connects, when it wants to have power, then it connects to the second one. So then that is creating a current through the relay, which is basically how all relays work. But I just learned about this, so I'm quite happy that I managed to put this together. And then when the relay gets a current through it, then the switch, like a coil, becomes magnetic, and it pulls the switch in and connects the three-phase leads, so the heater starts. So if I turn up the thermostat a bit to see if it connects, then it will. There you go. See, so then the thermostat connects and the current goes through. So if I lower it again, there it goes off. So that's basically how the thermostat controls the heating. So when there is no need for any heat, then this one turns off. Then there is no flow of cold water going through the heater, because it's just taking the existing water in the floor and just circulating it. So there's no added heat. So then this one gets warm, and then the thermostat recognizes that it gets warm, and then it turns off the power. And when it wants more heat, then it opens up the valve and it starts circulating in cold water into the heater again. And then the cold water cools down the thermostat. Thermostat connects the power. So that's how it works. And I've been using it now for 2 days. And it's been working perfect. Like, it's been working so good. I can hear it, since it's quite a loud relay. It really makes like a click. I can kind of hear it going like click sometimes, and then like 5 minutes later it's like click, goes off. Now the floor has been really cold, so I was, because of the winter, it's been standing cold, so I had like 15, like 12 degrees return from the floor, and I had like 30 degrees going out. But now they're basically the same, like it's 24 degrees centigrade, and yeah. No, it's actually warmer. It's like 28 degrees centigrade, and yeah, about the same there, almost 29, 30. So like it's now the system is quite balanced. And and it's never getting too warm when it's on. Like, it's getting kind of like not burning hot, but just so like you don't really want to keep your hand there for too long on this end, but because the water is getting warmer and warmer and warmer when it goes through this. But otherwise, like, I'm really happy with this system. It's not going to be the cheapest because it's just electrical power straight into the house. But I'm going to have a wood burning stove. So in the coldest months, I'm going to support the system with wood, by burning wood. I can also add, like, if I wanted to put on a heat pump on the system, I would do this on this part here. So then I would put on the heat pump here, and then this would be a backup. So if it senses that the pump is not really keeping up with the system or with the flow, like the water is not warm enough, I would have this like set on a lower temperature than the heat pump. So, or say like the heat pump delivers 35 degrees centigrade, then I would put this on 30. So if the heat pump is not keeping up, and if the output temperature of the heat pump goes below 30, then this would kick in and support it and keep it on 30 at least. So I have the option to adapt, like to expand the system into a heat pump, and a heat pump would be much cheaper to heat the house with. But since I found like this was free, like the system, like buying this finished would be around, at least in Sweden, like $2,000 or like 1,200 euros. So considering that I just saved not 2,000 American dollars, it's like $1.6 thousand. So yeah, so I'm quite happy with making this, and it's like the parts are very simple. Like, it's not something that will break easily. So yeah, I'm very happy with this. The rest of the tubing is just, this is like for filling the system. So this is like tap water. This is fresh water. So this is just to fill the system up if I need to. This is an expansion sustainer, whatever it's called. So it makes sure that the water is able to expand. into this container. So it's like a rubber seal halfway. So like a kind of like a balloon that allows that expand, like flexes, and allows the water to expand a bit. And when it gets too much, then there is the release valve here that releases that is like set on a certain, when it goes above a certain, I think it's like 2 bars or like 2.5 bar, then this starts releasing water out into outside of the house. So yeah, that's how it works. So yeah, till next time.